the difference between boiling point in ammonia and nitrogen gas. So in reference to the intermolecular forces, what intermolecular forces are there between N2 and N2? What intermolecular forces do we have here?
London dispersion force.
London dispersion force. Oh yeah, okay, London. It's fine. It's fine. So now we'll just say London forces. It's fine. London dispersion force. It's one and the same thing. London forces, right? Yes. So because nitrogen gas is a nonpolar, and then also nitrogen gas is a nonpolar. So forces between nonpolar molecule is London forces, London dispersion forces. All right. Then for ammonia, NH3, what do we have?
Hydrogen bonding.
Yes, hydrogen bonding because it's H bonded to nitrogen, which is, remember, I said H bonded to one of these, fluorine, oxygen, and neon. It's hydrogen bonding. So now you are going to explain the difference in the boiling point in terms of the intermolecular forces. So the way you respond to this, you're going to say NH2 has London forces, London dispersion forces. It's fine. Then ammonia NH3 has London forces. Then it has dipole, 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 and hydrogen bonding. Hydrogen bonding. Right? So which means this one is obviously going to be stronger. We're going to need more energy to break the bonds between ammonia than nitrogen because it has London forces, dipole, dipole, and then hydrogen bonding, which is just a special dipole. Then you will tell them that NH3 has a higher boiling point. Yes, has higher boiling point than, remember, you are comparing, refer to the intermolecular force and explain the difference. You are comparing, so you must use words that relate to comparison. Tell them that ammonia has a higher boiling point than nitrogen gas, than N2, right? Has a higher boiling point than N2. So which means more energy is needed to break intermolecular forces between NH3 than N2. We will need more energy to break intermolecular. Guys, write it in full. Write intermolecular forces. Write intermolecular forces. Because last year we were advised by the But a chief what of physical science. That woman said they no longer accept inter this thing. They no longer accept it. When I was in grade 11, I used to write it like this. But last year they said they want you to write in full. So more energy is needed to break intermolecular forces between ammonia than nitrogen gas. Then you are fine. You get your 3 marks. Yeah, I don't know how they will allocate the marks, but you can get 3 marks for that. So this is just in case maybe the question is 4 marks. You are fine in that way. Now, all right. 3.3. Explain why H2 will evaporate faster. This is in terms of vapor pressure for sure. Oh, I skipped a question. Write down the formula of substance on the table that will have the lowest melting point. Which substance has the lowest melting point? Remember, once a substance has a higher boiling point, if a substance has higher boiling point, it means it also have a higher melting point. So if it have a lower boiling point, it has lower melting point, just like that, and so on and so on. So now, which substance has the lowest melting point?
H2.
H2, yes. Yes. This one, H2. Because it has the lowest boiling point on the table. We're just going to write H2. Now the question says, explain why H2 will evaporate faster than N2. Refer to the type and relative strength of the intermolecular forces. Refer to the type and relevant relative strength of intermolecular forces. Okay. Um, it's fine. Let me remove this. Gone, and 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 gone. So we have N2 and N2. Both of them, they're London forces. They're both London forces. You see? Now you are talking about the relative strength of intermolecular forces. They are both London forces. But where is the difference coming from? This way, we're going to talk about the molar mass or the bond length, something like that. Remember, in N2, you are going to have a triple bond. I want to show you something. In H2, you have a single bond like this, right? But again, the molar mass of hydrogen is 1. The molar mass of hydrogen is 1 from the predictable. The molar mass of nitrogen is 14. You see? Um, which means nitrogen is much bigger than hydrogen. Nitrogen is bigger than nitrogen. So this N and this N, this is the distance between their nuclei. Maybe it's 4. For hydrogen, maybe it's 2. You see now, which means now the difference is brought by the distance between their nuclei or by their bonds. But I'm going to advise you, tell them about the distance or the molar mass. Or yes, but just tell them in any way because you are explaining. The explanation depends on you. Either way, you are still fine. So we said hydrogen and nitrogen, N2 and N2 have London forces. I think these are type of the question whereby you will be having options. Option A, option B, option C. The learner is talking about the molar mass. The learner is talking about the bonds order and so on. Still fine. Sometimes you can create the memo. If what you wrote is logical, they add your option on the memo. That's me. I used to create memos. I'm joking. I was the dumbest. So you're going to tell them that N2 has more, or let me just use higher molar mass, has a higher molar mass or molecular weight or molecular mass, it's fine, molar mass than H2, right? And then, which means more energy. No, yes. Explain why it will evaporate fast. Then what will happen if it has more molecular weight? Or I should have said hydrogen has lower molar mass than N2, but either way is still fine. So if a compound has more molar mass than the other, it means it will evaporate slower. Or yeah. It means it will take time for the compound to boil, to evaporate. Eh, so for this one, but the way you can conclude it, N2 has a higher molar mass than H2, then H N2, let me say N2 will have higher boiling point or will evaporate. The problem is they said evaporate slow. I don't want to answer this question, to answer that question by writing it here. So let's just say N2 will have higher boiling point. But I will send the options on the memo of the question, boiling point. Then I think you're fine here. Yeah, I think you're prop like that. Now, for 3.4, they said write the formula of the substance in the table with the highest vapor pressure. In our statement or in our first discussion, we were talking about the proportionality relationship between um, vapor pressure, boiling point, and melting point. And we got that vapor pressure is inversely proportional to the boiling point. So which means a substance with the highest boiling point will have the lowest vapor pressure. Then a substance with the highest vapor pressure will have the lowest boiling point, which means now this one, hydrogen gas, it has the lowest vapor pressure. It has the highest vapor pressure because it has the lowest boiling point. I hope we are fine there. And that is why in this question they said explain why H2 will evaporate faster than N2. It is because they're just giving you the answer for the following question, the memo for 3.4 right there. You see? So we are going to see they also want an explanation rather than the formula of substance with the highest vapor pressure. You're going to say N2. They said the formula, not the name. So you say H2, and then on your explanation, you tell them that mm, H2 has lower boiling. You're talking about this boiling point. Don't talk about melting point, which is not here on the question. Tell them about the boiling point. If it was melting point, you're going to use melting point. So you're going to say H2 has lower boiling point than N2 and NH3, right? So once it have a lower boiling point, it means that H2 will have higher vapor pressure than